We are going to look at another set of vocabulary words that are important to understand. And it's easy to mix these words up, but it's important that you use them correctly when you're in your physics class. So all three of them have to do with how quickly an object is moving, but they measure that motion in different ways. Velocity, by definition, is displacement divided by time. Notice that this will give us units of length per time. In other words, you can get meters per second, miles per hour. Speed follows a similar formula, except the word that I write on top is distance divided by time. Notice I will get the same units. This still gives me length divided by time. So both velocity and speed have similar formulas, and they are measured in the same units. This makes it so easy for students to mix up which one is which. The important thing to remember is that velocity, because it comes from displacement, will give us a different number than speed because it depends on distance. Think back to our mealworm lab. If you were there, we had a bug that was running around on a paper towel. Now, maybe your bug ran 100 centimeters in 20 seconds. Okay, that's the distance that his little legs wiggled around the paper towel. But because the mealworm didn't go in a straight line, it followed a squiggly, wiggly path. By the time the timer ended, the poor little mealworm was actually only 10 centimeters from where he started. And it took him 20 seconds to get there. Okay, so again, speed relies on distance, which is the full path. Velocity relies on displacement, which is how far you are from where you started. So I'm going to call this the progress. Are you actually getting somewhere? If we plug these numbers in, 100 divided by 20 means that little worm was going 5 centimeters per second. Way to run, little fella. But if I plug in these numbers, 10 divided by 20, I only get 1/2 of a centimeter per second. So notice that velocity and speed can give you very different numbers. If the object follows a straight line, then speed and velocity will give you the same value. But if the object squiggles or wiggles at all, then speed will give you a bigger number than velocity. And this is just because if you're squiggling and wiggling, that's not the most efficient path to follow. It's also important to note that velocity can have a positive or negative direction. So I'm going to put plus or minus. But speed can only be positive. In other words, speed doesn't have a direction. Because the path squiggles and wiggles, we cannot define which direction it was going. And so we always give it a positive value. Velocity, on the other hand, we can define that one direction is forward and one direction is backward, and so that allows us to have positives or negatives. Okay, the last vocabulary word we're going to see more in future units, and that is acceleration. Acceleration is your change in velocity divided by time. So this is going to be delta V on top. Basically, if the object is gaining velocity or losing velocity, then it has acceleration, and we will talk a lot more about that later.